The sun beat down on the ancient stone, warming the millennia-old surface of the Pont du Gard. Today, it stood as a silent, unbroken testament to Roman ambition, its soaring arches cutting through the French countryside like a colossal, weathered smile. 2,000 years had passed since the Romans first carved this engineering marvel from the earth, yet it remained utterly intact, a living monument to a civilization that understood stone, water, and the sheer power of human will. This wasn't just a bridge, it was a hydraulic masterpiece, a lifeline for the city of Nîmes, built with precision that defied the limits of its time. And it was still standing. That was the hook. The Pont du Gard wasn't built in a flash. It was a slow, deliberate act of engineering unfolding over decades. Construction began around 19 to 20 AD, during the reign of the Roman Emperor Tiberius, though the exact start date remains debated by historians. The Romans needed water for Nîmes, a bustling city in the province of Gallia Narbonensis, and the Pont du Gard was their solution. It wasn't a simple channel. It was a complex system designed to carry water from the distant springs of the Gardon River, over 40 kilometers away, to the city's aqueducts. The aqueduct's path followed the natural contours of the land, a careful balance of gravity and geometry. Its most astonishing feature? Its sheer scale. Stretching over 10.5 kilometers, it was the longest Roman aqueduct in the world at the time of its completion. At its highest point, it soared 48 meters above the ground, enough to ensure the water flowed steadily without spilling, even during heavy rains. To understand how the Romans achieved this, you must imagine the labor that went into every stone. The aqueduct's foundations were laid deep into the bedrock, using local limestone that was quarried and shaped with chisels and hammers. Workers laid the first courses of stone with meticulous care, ensuring each block fit perfectly into the next. The arches themselves were built in a series of 108 segments, each one a carefully calculated curve that distributed the weight of the water and the structure itself without collapsing. The Romans didn't use mortar in the traditional sense. Instead, they relied on the interlocking of the stones and the natural compression of the limestone. This technique, known as opus cementitium in some contexts, but more accurately opus reticulatum for this specific structure, allowed the aqueduct to withstand the immense pressure of the water flow. The water journey was no small feat. It began at the source, where the Romans tapped into the natural springs near the Gardon River. From there, the water traveled through a series of channels, carefully designed to maintain a steady, controlled flow. The aqueduct's design was so precise that it could carry up to 100,000 liters of water per minute, enough to supply the needs of Nîmes population, which numbered around 50,000 people at its peak. The Romans used a clever system of siphons and channels to direct the water into the city's reservoirs, ensuring it reached every corner of the urban center without significant loss. This level of engineering was revolutionary for its time. The Romans had no advanced tools or machinery. They relied on human ingenuity and a deep understanding of physics. The aqueduct's ability to function for centuries without major repairs was a direct result of this careful planning. The Pont du Gard's endurance speaks volumes about Roman engineering. Unlike many structures of the era that crumbled under the weight of time, this aqueduct has survived because of its design. The Romans built it with the knowledge that the earth itself would provide stability, and they used local materials that were both strong and readily available. The limestone they chose was ideal for the task. It was durable, resistant to erosion, and could be shaped with the tools of the time. The aqueduct's arches, each spanning about 10 meters, were designed to distribute the weight evenly across the structure, preventing buckling or collapse. This was no accident. It was the result of years of study and practical experience. The Romans had already built aqueducts in other parts of the empire, but the Pont du Gard was unique in its scale and the precision of its construction. Visuals of the aqueduct today reveal its enduring power. The stone is worn smooth by centuries of weather and human touch, yet it remains strong. The arches, though partially collapsed in places, still hold their shape, their curves a testament to the Romans' mastery. When you stand beneath the aqueduct, the water flows steadily through the channels, a quiet reminder of the engineering that once sustained a thriving city. The aqueduct's path winds through the landscape, a silent witness to the Romans' ambition. In the distance, the modern city of Nîmes lies below, a stark contrast to the ancient world that built this marvel. The Romans didn't just build an aqueduct. They created a system that transformed how cities functioned. Before the Pont du Gard, water was scarce and difficult to manage. The Romans solved this problem with a design that was both practical and elegant. The aqueduct's ability to carry water over long distances without the need for pumps or mechanical assistance was a major breakthrough. It was a system that could be maintained with minimal resources, a hallmark of Roman efficiency. The Pont du Gard was not just a structure. It was a lifeline for the city of Nîmes, ensuring that its people had clean water, food, and the resources they needed to thrive. To see the aqueduct in action today is to witness history in motion. The water flows through the channels, a steady, unbroken stream that has traveled the same path for 2 millennia. The arches stand tall, their curves a reminder of the Romans' understanding of physics and their ability to work with nature. The aqueduct's design was so advanced that it could carry water over steep gradients without losing pressure, a feat that would not be replicated until the 19th century. This was engineering at its most practical and enduring. The Pont du Gard remains one of the most impressive examples of Roman engineering. Its scale, its precision, and its longevity are a testament to the Romans' ability to solve complex problems with simple, effective solutions. It was built with the knowledge that the earth would provide stability, and the Romans used that stability to create a system that would last for centuries. Today, it stands as a silent reminder of a civilization that understood the power of stone, water, and human will. If you enjoyed this story, please like and subscribe for more amazing discoveries.